By using the substitution u equals secant of x or otherwise, find an expression for the integral from 0 to pi over 3 of secant to the n of x times tan of x with respect to x in terms of n, where n is a non-zero real number. So as we know, secant of x is just 1 over cosine of x. The first step over here is to first differentiate both sides of this equation. So we get du equals secant of x times tan of x with respect to x over here, and then we can divide both sides by secant of x times tan of x to isolate the x, with the goal over here basically trying to get this whole integral to be in terms of u, and then simplifying it as much as possible until we get an expression in terms of n. So since we've done this, we also need to change our bounds. So we can plug in 0 and pi over 3 into x over here. So we get secant of pi over 3, that's just 1 over a half, which is 2. And then secant of 0 is just 1 over cosine of 0, that's also just 1. And now we can plug all of this in here into our integral. So the bounds change, they're from 1 to 2 now. And we get secant to the n of x times tan of x. And this is just du over secant of x times tan of x from here. And now if we simplify it further, notice that the tan of x cancels out. And then if we use our exponent laws, we know that since the bases are the same, we can subtract the powers. So we get the integral from 1 to 2 of secant to the n minus 1 of x with respect to u. But now we need to get this expression over here to be in terms of u. So we can actually raise both sides of this equation to the n minus 1. So then we get u to the n minus 1, which is equal to this, giving us this integral. And now that it's fully simplified, we can simply apply the power rule. So we can add 1 to the exponent here, and then that goes to the denominator. So if we add 1, we get a u to the n, and then that n goes to the denominator, and the bounds stay the same. And now we can plug in those bounds. So we get 2 to the n minus 1 to the n over n. 1 to the n, that's just 1. And then since we have a common denominator, we can rewrite it as this. And that's our final answer.